In Unit 5, we're going to focus on operations with polynomials. So this includes adding, subtracting, multiplying, and dividing. And we're also going to look at factoring, so how to rewrite a polynomial into a product. So the first thing that we're going to look at in this unit is addition and subtraction of polynomials. So basically, this is just when we say combine like terms. You're just adding or subtracting polynomials. Before we begin with adding and subtracting, a couple of definitions that you have to know. The first one, a polynomial, is a finite sum of monomials. So monomials are terms. So here's just some examples here. These are polynomials because they have terms that are being added or subtracted. When we say a finite sum, remember you can think of adding a negative as addition, and it's the same as subtracting. Down below here, we have, when we talk about polynomials, we can classify them by the number of terms it has. So a polynomial that has 2 terms is called a binomial. A polynomial with 3 terms is called a trinomial. And like we said, a polynomial with 1 term is called a monomial. So we also refer to a monomial as a term when we're talking about combining. And then the last definition here is the degree of a polynomial. So the degree of a polynomial, one variable, is the highest power, so the highest exponent to which the variable is raised. So let's look at an example here. When I look at this first polynomial, the highest exponent, or the highest power, is a 5. So we call this a degree 5 polynomial. And the classification, what type of polynomial it is, well, there's 3 terms. So this is a trinomial. So then let's look at this other one. So this example here, I have my highest power is going to just be an x. And remember, this x is really like to the first power. So this is a degree 1 polynomial. And it has just 2 terms. So that means it's a binomial. The next one here, we have 3 terms. So it's a trinomial. Highest power is 2. So it's a degree 2. And this next one is just 1 term, so this would be a monomial. And the highest power would be 5, so it's a degree 5. And the last one, -9. So -9, really, if you wanted to think of this with like an x value, it would really be -9x to the 0 power, because anything raised to the 0 is just going to equal 1. So this is the same thing as saying -9 times 1, which is just -9. So we would say that this is a degree 0. Anytime you have a constant, it's just a degree 0, because of this down here, that x is really raised to the 0 power in order to make it a 1. Or whatever the variable is, it's raised to the 0 power in order to be able to get 1, so that when you multiply by 1, it's not changing the constant. So this is also going to be still called a monomial because it's 1 term, but we also call this a constant, our constant term. Lastly, before I move on, just going back and looking at these, all of these polynomials are in standard form. Standard form means that the highest power is first. So if you look, all of these, I was able to look at really the first term. Because of these being in standard form, that means the degree is actually in front. It's the highest power. If these were not in standard form, you still have to look for the biggest degree or the biggest exponent to figure out the degree. But typically when we write polynomials, we'll write them in standard form. So standard form just means the exponents are in decreasing order. So if you're looking at this first one here, it's in standard form because the exponents go 5, 3, and then 0 for the exponents. And again, the highest power is in front, which means the degree is in front. So just keep that in mind. Standard form just means that the exponents are in decreasing order. So then let's look at some examples of how do we actually add or subtract polynomials. So for this one, I'm going to add these 2 trinomials together. So first thing you want to do is if you have anything outside of parentheses, you want to make sure that you distribute that through. I do not have anything outside of parentheses, so I can go ahead and just drop those parentheses since there's nothing out in front. So I'm just going to rewrite this, dropping the parentheses. And then really all you're doing here is you're combining like terms. So like terms mean you have to have the same variable with the same exponent, so x squared and x squared. And when you're adding monomials, you're just really coming up with how many of these x squareds do you have. So you keep the x squared and you're adding the coefficients. How many of these do I have? Well, I have 6 x squareds. So that takes care of that term. Then I go to the next set of like terms. So I have this minus 5x and I have a plus 7x over here. Again, how many do you have? Well, you have negative 5 of them and positive 7. So that means together you would have positive 2x. So you're just subtracting or adding your coefficients, negative 5 plus 7, or you can think of it as 7 minus 5. And then your constant terms. So I have 3 and I have negative 8. So you add those, we get negative 5. So again, subtract your integers, keep the highest, keep the sign of the higher absolute value, which is 8. So I kept that negative because of the 8 being the bigger number. So that's it for that one. So let's try another one. So this is a subtracting one, which is really going to be the same thing as adding. The only difference is this first step. So for the first trinomial here, it's just going to be 3x squared plus x plus 4. But then this trinomial here, you have to distribute this negative. This negative is like having a negative 1 out in front. So what's going to happen is that all of the signs are really just going to switch. So I'm just making all of those plus signs negatives because I'm just multiplying everything by negative 1. And now we go back to how we just did the last one. I'm just going to look for any terms that are like terms, and you're going to combine them. So this negative x squared really has a coefficient of 1, negative 1. So it's asking again, how many x squareds do you have? Well, 3 minus 2. If I have 3 and not 3 minus 2, 3 minus 1. If I have 3 and I subtract 1, I have 2 left. And then I'm going to the next set of like terms. So I have the x's. So I have negative x here because I have plus 1 and minus 2, so a negative 1. And then your last thing here are your whole numbers, plus 4 minus 3, so I'm going to have plus 1. And that's it. So you're just combining like terms, just keeping in mind to distribute any negatives first. So looking at this example here, I have a couple things that I should do. I have a couple negative signs. So before I worry about these brackets, I'm going to go on the inside and work the inside out. Just like, you would with PEMDAS, you'd always work in parentheses first. So I'm going to do 4x minus 3. And I'm going to keep that 2 minus, and I'm going to go ahead and distribute that minus sign first. So I'm going to make it minus 3x minus 4. Make sure that you're paying attention to the minus and you make sure that that 4 gets the negative as well. And now what I'm going to do is I'm going to combine my like terms in the parentheses. Remember, you want to do the operations in the parentheses first. So I'm going to carry down this other stuff. And when I combine my like terms in parentheses, the things that I can combine are just the numbers here. So 2 minus 4 is going to give me negative 2. I'm subtracting those and keeping the negative since the 4 has the negative. And then I just keep the minus 3x. And now I have another set of parentheses. So now I need to distribute this negative 3. So I have 4x. Negative times a negative is going to give me a positive 6. Negative 3 times a negative 3x is going to give me a positive 9x. And again, we're combining like terms. So I have my 4x and my 9x. I can combine those. I get 13x. You just add your 4 and your 9. And then keep the plus 6. So whenever you see multiple sets of parentheses, make sure you work from the inside out, keeping in mind to distribute. So let's try a couple more. So this example here, again, we have different sets of parentheses, so we're working from the inside out. So I'm going to keep this 2x plus 3. I'm going to keep it, but I'm going to go ahead and drop the parentheses since there's nothing in front of it. So it's just going to be 2x plus 3. And I'm going to keep these big brackets for right now. And I'm going to worry about, let's reduce the stuff inside here. Let's take care of that. So the 3x plus 1 is just going to become 3x plus 1. I don't need to worry about doing any distributing. But the next step here, I do need to worry about distributing that negative. So it's going to be minus x plus 7. And these are all in the big brackets. And now what you need to do is you need to combine anything in these big brackets. So I have a 3x and a minus x that's going to get combined. So let me go ahead and just rewrite this. So I have 2x plus 3 minus, and this is all in brackets. So I have 3x minus an x is going to be 2x. And then I had a plus 1 and a plus 7. So that's going to be a plus 8. And now I've combined everything I can in the brackets, so now I can go ahead and distribute that minus sign. So I have minus 2x minus 8. And when you look here, we have the minus 2x and the positive 2x. If you have 2x and you take 2x away, those are just going to cancel, so we don't need to worry about those anymore because it's just going to end up being 0. And then with my numbers, I have plus 3 minus 8 is just going to give me negative 5. And that's it for that one. So one last example here, just something that's slightly different. For this one here, we want to find the value of 3x squared minus 5x plus 4 when x equals negative 2. So really what that means is we're just going to substitute in x minus 2. So when we substitute in, though, remember we always plug in using parentheses so that we make sure we take care of the negatives. So I'm just going to rewrite this entire thing by putting in a negative 2. And now I'm going to go ahead and I'm going to simplify this. So when I simplify this, the negative 2 is the only thing that's getting squared because the negative 2 is in parentheses. So it's the negative 2 that's being squared. And remember, it's negative times negative, which means it's a positive. So it's going to end up being 3 times 4 because when you square the negative 2, you'll get 4. Here we have negative 5 times negative 2 is going to be plus 10. And then plus 4. Here we have 12, and then we have plus, I guess we'll just combine these, so we have plus 14. And then lastly, combine the 12 and the 14, so we have 6 and 2 when we combine the ones, so we get 26 as our answer for that. So whenever you're replacing the variable, you should not have any more variables left. Your variable should be gone, and you should just be getting a number. So that's really it for adding and subtracting. It's really just combine like terms. Just make sure that you only are dealing with terms that are the same when you combine them, and you're only adding or subtracting the exponents and just carrying along the variable part.